So here in this problem, we have a harmonic progression. The first term is 2 over 5 and the second term is 12 over 13. So that is provided to us. We need to obtain the largest term of the harmonic progression. So let us begin. Now, since it's given here that the first term of the harmonic progression, so that has a value 2 over 5. So if we know the term, any term of a given harmonic progression, then we can also find out the first term of the corresponding arithmetic progression. All we have to do is take the reciprocal. So that will become 5 over 2. And then we are also provided with the second term. So the second term of the harmonic progression, so it's given here, it has a value of 12 over 13. So that means the second term of the corresponding arithmetic progression will be, all we have to do is take the reciprocal. So that's going to be 13 over 12. Let's label this as number 1 and this is number 2. Now, what we'll do, we'll consider an arithmetic progression. So let us suppose that the first term be A and the common difference be D for an arithmetic progression such that the first term, which is already provided to us, A, is going to have a value 5 over 2. Now we need to find out the common difference D. All we have to do is take the second term, which is 13 over 12, and from it we're going to subtract the first term, so that's 5 over 2. So this is going to give us a value minus 17 over 12. Fine. So that is the common difference. Now that we have the value of the first term and the common difference, well, let's find out the nth term. So the nth term of the arithmetic progression, which is represented by an, so that's given by a plus n minus 1 times the common difference d. So we'll substitute the value here. So a is 5 over 2 plus n minus 1 times the common difference, so that's negative 17 over 12. So we have 5 over 2 minus n minus 1 times 17 over 12. So we have 30 over 12 minus n minus 1 times 17 over 12. So let's take 1 over 12 as the common factor. So we have 30 minus 17n plus 17. This will be equals to 1 over 12 multiplied to 47 minus 17n. Fine. So this is the nth term of the arithmetic progression. So we'll try to find out the nth term. So this implies that the nth term of the harmonic progression, all we have to do is take the reciprocal 1 over an. So that will be equals to 12 divided by 47 minus 17n. Now our task is to find out the largest term of the harmonic progression. So let's say this is the largest term. So let 12 over 47 minus 17n be the largest term of the given harmonic progression. Now if it were to be the largest, then 47 minus 17n must be the least. Only when it attains a least value, then the entire fraction is going to have a highest value. So for what values of n, this is the least as possible. So if we choose n to be equals to 1, then we have 47 minus 17, so that corresponds to 30. So if we take n equals to 2, so that corresponds to 47 minus 34. So this will be 13. If we choose n equals to 3, we have 47 minus 51. So this gives us a negative value. So we have negative. So this is the only possible value. So n equals to 2. So that means the second term is going to give us the largest term of the given harmonic progression. And we don't have to find out the value, that's already provided to us, the second term, which is 12 over 13. So this is going to be the largest term. So the largest term will be 12 over 13. That's the final answer.